Okay. Okay. So welcome to the class. So we are going to have at least 4 schedules. So 1 hour TA class, 1 hour class today, and then also Thursday at the evening time, and also Friday morning. Okay, so 2 hour for Friday morning. So 1 hour class, 1 hour class, 2 hour class, and 1 hour TA. By the way, your TA, please come to the front. And this will be your teaching assistant. So please come to the class on Monday for your TA class. So you can introduce yourself.
Thank you. Good morning, everyone. My name is Andromeda Laksono. I'm from Material Science and Engineering. Now I'm third years of PhD programs. And nice to meet you. For my class, we will conduct in every Monday at 10 until 9. Okay, I think just thank you.
Okay. Let me continue for just a bit of introduction. Okay. So yeah, welcome to the calculus class. This is the fastest way to reach me. So please take your notes for my email. So if you have anything to ask or any requests, anything to ask. Okay. Or you can also chat me through Moodle, but sometimes Moodle can be delayed. It depends on the server. If it's if it is too much loads on the server, sometimes the message got delayed. So I think the fastest way is just through my Google account, Google NTST Google account. Okay. And yeah, I think most of you are familiar with calculus. Some of you already taken my class before, and unfortunately not be able to pass my course. So yeah, I'm welcoming you again in my class, and I think we can talk about the course a little bit. So the course will be based on this textbook. As usual, I think some of you are also getting the same information last time. And what I want to mention here is these 2 last sources. So this will be Wolfram Alpha, which you can use right now. If you go to the website wolframalpha.com, you can put any computations, any instructions you want, okay? Mathematical computations. So it's like, and sometimes you can also answer your general science question or even social science. They can answer, but it's not like ChatGPT. Okay? ChatGPT is like language word processing, but this is computation. It's different system. Okay. But if you want to get the answers like really smart, like a robot, it's ChatGPT. But this one is basically you give information and you give instruction, compute something, and it will compute for you. But if it's asking you to provide something, blah blah blah, it won't understand your questions. So it's basically just compute something, or maybe explain something. But the context sometimes is not as smart as the AI. It's different, but it's still powerful. And if you pay the subscription for ChatGPT, you can have this Wolfram Alpha plugin. So you can compute mathematics through ChatGPT also. AI is good for you, but if you use it wrong, in the wrong way, then you will not get benefits at all. It's good for you for brainstorming ideas, write some paragraphs, corrections, but at the end of the day, the one who decides, the brain, is human. Okay? it's just a tool. This is also just a tool, just to help you maybe verify your calculations, verify your results. You can use one from often. The last one is GeoGebra. It's for graphics. You can graph using this GeoGebra, or you can find other websites such as Desmos, or even using some software. Like if you are familiar with MATLAB, I think it's very good for visualizing some graphs and maybe compute something. And it's good for like 3 dimensions, right? This also can be done for 2-dimensional or 3-dimensional graphs, and it's quite easy to use. Okay, so you can check this website, and if you want to know more, you can check the tutorial. You can check also the library. It has a lot of library that you can check throughout the website that has a wide range of topics, from like elementary school mathematics through university level. Okay. So it has quite large library. And you can specify the topics. For example, you want to know more, or you want to review like derivatives, or you want to review limits. It can give you some context and the example of the graphs. And sometimes it is easy to use. Maybe sometimes in the middle of the class, especially at the early class, I will try to use some of the graphs in the GeoGebra. Okay. Okay. So the books is the James Stewart 9th edition. Okay. 9th edition James Stewart. I think they have 2 different books, but they are the same. This is the first one. The second one is the transcendental or the essential part, which is more simple, and I think most of the local students prefer that. But the content is the same. The content is the same. I think if you want to go for I think the Chinese version, I think they have, or like with the supplementary of Chinese notes, I think they have, but I'm not sure. We can check. Okay, you can check. Okay, the evaluation will be 25 for quiz, 20% for midterm. Teaching assistant 10%. So 10% is based on perhaps your attendance, and maybe your TA can also give you some quizzes to check your understanding. Also attendance and participation in class. I'm giving you 15% to make sure that you come to the class and get this 50%. Okay? So please do that. For today, there will be no attendance. I mean, still okay, but it will be counted starting from the next class. I think the Thursday class. Final exam, 30%. Okay. 25, 20, 10, 15. Participation, including the sometimes in 1 week, at least one class will have like a post test. So every class ended, I will give you some questions, and you need to participate. It will be like an online test using just your smartphone. Okay. That's the evaluation. And then this is what we are going to cover for the whole semester. So starting with the parametric and the polar, sequence, series, power series, okay, vectors and geometry of space, vector functions, partial derivatives, multiple integrals. Okay. But in this calculus 2, the main part is actually these 2. This is the last 2. The first one is actually kind of similar context with the calculus 1. The difference is just we are using the techniques in calculus 1 into different conditions. For example, we are using it for parametric, okay, and then we're using it for polar. So we convert the Cartesian to polar, okay, and using the calculus to solve the problem. And a sequence, series, and power series is like additional topics, and in describing the process, we are going to utilize some calculus. Okay? Vectors and geometric space, this is also additional. Not really related directly to calculus, okay? But we are going to use it, or we are going to need these vectors and space for the vector functions, which is essential for the partial derivatives. Okay? So that's why this is need to be done. But I think some part of the vectors and geometry of space, I believe you've got it from physics and from other mathematics course. So I will skip some part of it and focusing on what we are going to deal with in the next chapter. So maybe only some sections will be skipped, especially the introduction of the vectors. Okay. And then partial derivatives, I think this is essentials. Okay. This will be, I think, useful for your future courses. If you still need to take any courses next semester. Okay. And then the multiple integrals also important. Okay, that's the topics. And what else? Okay, this is, I think, just some tips for you. Okay. Since this is actually if you see some courses that has part 1, part 2, it means that sometimes when you are entering the part 2 of the course, which is this calculus 2, you need to understand all the things in calculus 1. Okay, and I don't think we have the time for review all the concepts. Okay? Maybe I'm giving you like tips and just a few notes from calculus 1, but I don't think we can cover all the things in calculus 1. So what you need to do is you need to catch up that gap of calculus 1. Okay, so mastering algebra, trigonometric functions, this is very basic in mathematics, and I hope you already have some way to master it. Okay? You can use many resources online. There are a lot of YouTube videos in English and Chinese. There are a lot of YouTube videos. Please check that out. Especially if you are if you focus on like specific topics and you want to know the foundation, the fundamentals. I think you can check you can also check some part of calculus through Khan Academy, but that is for the very basic, very foundations of the concept. Okay. But after that, what should you do is basically you need to repeat what you know. Okay. You need to practice. Perhaps you can have a group discussion, or maybe practicing in some problems. Okay. And like I said before, use maybe visualizing tools like graphing calculators or a website or any resources. And I think you can also check some AI platform. For me, that's important because in the future there are more and more AI technology that will come. So we need to embrace that. So like, but you need to use it wisely. Sometimes students, when they are given assignment or homework, perhaps they ask ChatGPT and it gives answer, and you just copy paste that answer to your homework. You will not get anything from it. Okay. What you need to do is you need to utilize this AI to help you learn, to help you study. You know, you can create like step-by-step study in ChatGPT if you use the correct instructions, the correct prompt. Okay. And I think that will be beneficial if you want to use that. And then reasoning. So if you get some theory from my class and I'm giving it like some proof, and here's how to do it, blah blah blah. For me, learning mathematics or learning calculus in general is not the same as memorizing formula. Okay, so do not memorize formula blindly. It's good for you to memorize, but if you don't understand what that is that formula will be meaningless. Okay? So And sometimes I forgot the formula, but I know how to get that formula. So I will go back to the root, to the scratch, and then try to look for that formula and how to get that and how to use it. So please try to find a way learning mathematics that way. Okay? And I think study has, like everyone has different unique learning ability that you need to find out by yourself. Sometimes maybe some students prefer like in a study in a group and they explain to each other and everyone has order for who will be teaching who and etc. Or maybe someone just going to the class, just listen to the lecture and doing it individually. Someone or some students prefer that way. It's okay also, you could try that. But you need to find which way you are going to be better. Okay. Sometimes if you just like reading, passive reading, and not doing anything, in my opinion, it's not really enhancing your ability. Okay? Sometimes you need to do some works, repetitions, and when you teach someone, try to talk and explain something. If you don't understand, and if your friend doesn't understand what you're saying, it means that you don't understand the concept. So you need to try, find a way to learn. Okay? So, and then practice past papers. I think you can ask maybe your senior if they have some materials. You can check what kind of question it might be in the exam. That is also good. Okay? And okay, keep optimistic, positive. Okay? Manage your life, manage your study effectively. Life is not about only study, but you have also other things to do, right? You need to go to sleep, play, have fun, right? So we keep it in balance. Because if you are accumulating like stress out of your life, perhaps you will get some issues on your mental, and I think it's also dangerous. So let's keep that in mind. Okay, I think that's just for my tips, and I would like to move to the lecture. But before that, how many of you need the code? How many? Okay. After the class, or you can send me an email, and I will give the code attached into the email. Okay. I hope you already take notes for my email. Okay. All right. Okay, we can go. Okay. Okay, we are going to learn about parametric equation, but before that, I think I need to deal with some okay. Find the domain of the functions. This is just to can think like a warm up before exercise. So find the domain. Okay, what is the domain? Domain is if you are living in dormitory, you have how many beds now? 4, 5? Oh yeah, 6 for the ladies. So you have, let's say you have 6 beds, and each one of the beds, like each person, they have their things, right? Inside their territory. Okay. So if you take your friend's, let's say, glass and take it to your territory without telling your friend that you are taking it, is your friend getting confused or angry? Or no, it's just like, okay, you're like family. I mean, if it's a stranger, you're not really close to the person. It will be awkward, right? So your territory in your beds, you can think like that is my domain. You don't take anything from that. Okay? It's like that's your domain. It's supposed to be here, not there. Okay, that's your domain. So
I have a question. What's the number before the x in the first root?
here,
Now the second function.
this one,
Yeah. What's the number?
4.
4. Okay.
Yeah, 4. Okay. Okay, maybe a little bit, zoom a little bit. Okay. Maybe writing more. Okay. Okay, what should you do if you have questions like this? So if the question is just like x squared plus x minus 2, like if this is just a function, like maybe function a, if this is your functions, then I think every number is possible. So you can say, oh, all numbers okay with this. But here, only specific numbers, right? Because what? Because some numbers make something like this. So if you take 2 and then somehow you get 0 on the bottom, this will be undefined. Okay? In mathematical, we call undefined. And we have also square root. Anything inside the square root at least should be 0, right? Can it be 0? Can it be 0? Huh? Yes or no? Yes, right? Yes. Can it be negative? No. So we need to make this greater equal 0, right? Everything inside here needs to be like greater equal 0. So what we need to do is taking this inside and make sure that that inside part is at least 0. Okay. So we take this and then this. So x is right, and x squared is that way. Okay, or if you think this inequality makes confusing, and sometimes if it's in exam, you will feel nervous, right? What I can suggest to you is take this line number. Just make a line, and just solve it like usual. So you can imagine that this is equal, and this is equal, and then put all the numbers here according to their value. So the most negative is on why is it disappear? And put all the most negative on the left, which is the 4, negative 4, negative 1, and 1, right? And then since we include all the equal signs, so it should be full dots like this, right? But the whites disappear. Okay. Now what I need you to do is check each area. Is it negative? Is it positive? And then check to what you need to do inside the square root, okay? Or here, whether it's correct or not. Oh, why this is -4? It should be 4. Okay, let me change this. Wow, why it's disappear? Anyone using GoodNotes? I'm trying the trial for the GoodNotes 6, but it's okay, but sometimes it's weird. Okay, so we can conduct that. If we take 2 inside, let's say this 2 here, to check here, I think they are okay. So it's okay, so this is with a positive, right? And then if we take 0 here and check all the numbers, we see that this makes a negative, right? And we don't want that. And then we take below the -1, which is -2, we can take, and it's positive. So we can take that as domain is sorry, it should be include. It's not clear. Sorry. Let me write clearly, bigger. And then for the above equations, like this equation here, what you need to do is to make sure that it is not 0. So we need to make sure that this is not equal to 0. Okay? And that is what we are going to do. So we are just first just make it like usual quadratic functions. We try to factor. I think no. I think should be plus here. So we have. So we get that D should be x not equal -2 and x is not equal 1, or if you want to write the interval, hopefully you're getting used to this kind of algebra basic questions, algebra functions. Okay. Okay, just a little bit review, and let's jump into the first chapter of the courses, which is the chapter 10 in your textbook, the parametric equations. So sometime in the class, I will try to make some review like this from some chapters in Calculus 1, especially for the derivative and integral techniques. That is basically needed in Calculus 2. Okay, so let's go to parametric equation, okay? I believe this is just a warm-up. And I will record all the classes, so you can just review from the video that I will upload later on, okay? So first, let's go to the parametric equations. So let's say if we are having this, okay? Okay, they are given f with a new parameter t and g with new parameter t. Let's say I will draw the same graph without this context. Okay, I will draw the same, similar looking graphs, but different context. Okay? So let's say I'm drawing this. I'm trying to make it kind of similar, but without. Let's say that is similar. Okay, just that. Let's say I will name it. This function of x. Okay, what's the difference aside from my picture that is not too similar? What's the difference between the left and the right? Okay. If you see on the left, you see the context. They're adding something inside this, and also they have this, the arrow, right? It has direction. Okay. On the side, I just give you like a graph as usual, and I'm naming it a function of x or f of x. My question: can you make this as a function? Now you are thinking, what is the function? And I will ask one of you. Not me. Correct. That's the answer that I want to hear. So, how can you distinguish a function? What you need to do is take vertical line. Okay? So when you do this, you cross 1, 2, 3. If you cross more than 1, it's not a function. Okay? That is very basic from Calculus 1 or from basic math as well. So it is called the vertical line. So it's not a function. So what about on the left? On the left, we see that we can think this is like a trajectory, like a motion from maybe particle. And then we can think t as a time. You can think like that. And xy is the position. Okay. So every period of time, maybe t equals 0, t equals 1, t equals 2, it's like moving and change directions. So the function itself has one additional parameter, which we call, this is our parameter. Okay. Parameter variable, usually t. Okay. So we could say, and we could describe x is a function of t, as well y, also function with different symbols, also function of t. And we call this a parametric curve. Okay? Like for example, if I give you this type of function, okay, and we can pinpoint any t, like maybe start from -2, -1. Of course, if you think, can time be negative? Well, don't think like a time. It's not like a how to say it? The time is not start like, okay, 0 and then +1. Well, it is the number. Okay? The description of time just to help you to visualize how can it be logical in a way. Okay? So let's say we can try some t, maybe from -2, -1, 0, and then we can plot this point. Okay, and then we can make this directions. Okay? Maybe t equals -2 start from here, -1 here, 0 here. Okay, and then we are going to connect all of them. Okay. Do I have the picture? No, I think. Okay, no. So you can check t, x, y, and check from -2, -1, 0, and you will get some calculation here. You can check, for example, I will check just a few points here. 4 plus 4 is 8. So let me just write 8. -1, 3, 0, 0, 1, and then you can check other point as well. And then somehow it will be, if you make just the graph, and I hope you can try by yourself, it will be like a parabola. Okay, let me make it clear. Okay, like that, and starting, this is the important point is here, t is equal 0 is there, t equal 2 is there. Because if you see the equations and you try to plug in 0 and 2, it is on the x equals 0. And you can also see that this will be t equal -1. When you try to input t here, then y equals 0. Okay? And you can also check for the other point as well. So we could see that. Well, okay. If we think this like a parabola in a Cartesian xy, then there must be something to be done with these two parametric equations. So we could think that we could make this t y minus 1, and we can try to maybe substitute to here, which we can have which we are going to get y squared minus 4y plus 3, which is parabola, right? Which is a parabola, and because it's y squared and x like a functions, then it will be parabola that signs like this. Okay. And if you are trying to find the roots, then we get -1, -3. So this is y equal 1 and y equal 3. So this will be 1. This will be 3. This is y. This is x. Okay. Okay, another the important shape that can be described by the parametric is also like a circular shape, and that this will lead us later to the polar. So for example, if you have x equal cosine t, y equal sine t, and then it's described from 0 to 2 pi. Okay, so this is the first category. You have like parabolic equations, quadratic equations that can be implemented inside a parameter. Okay. And another thing is if we include trigonometry like cosine and sine. So whenever you see a parametric equation that involves sine or cosine, we need to think on how to implement those two. Okay. So if you think on the trigonometric identity, sine squared plus cosine squared is equal 1. So perhaps we can make that as our xy. So we can have x squared plus y squared, which is equal 1, which is a circle, right? So we could think that way to make this as or maybe this is cosine and then sine squared t, and this is equal 1. Which is perfectly, we have this circle. And of course, we could try to pinpoint all these positions through all our parametric here. So we can try from 0 until 2 pi. And maybe we could just take the special value in trigonometry. Okay, we can take pi over 6, pi over 3, pi over 4, okay, and etc., pi over 2. Or just 0, pi over 2, pi, and then 3 over 2 pi. Okay? And it will be a perfect circle which has the direction. Okay? And the directions for the circle, if we are using the radians, it will be this counterclockwise, right? And then this will be important for our basis later for understanding the polar equations. But for now, this is in parametric. So we still in x and y, but we add one variable called the parameter t. Okay, and let me go for the. Let me check. Okay, let's go for. So calculus with parametric curves. Okay, we have first the tangents. And you remember what is the tangent? What is the tangent? What's in Spanish? How you say it in Latin? Tangente. Tangente. Yeah. I believe the word came from Spanish, right? Probably. Okay. What does it mean? Like when you learn in Spanish, what does it mean? To touch in Spanish also, right? Yeah, so tangent means to touch. So if you imagine, you have a line like this, or perhaps let me just draw the curve first, like that. And you have a line alongside this curve, okay? That, of course, because the limited pixels from my Apple Pencil through the iPad, this area here seems all touching central points, right? But the definition for the tangent is we are going to have a line, like really straight line, and a curve. They are touching on exactly one point. Exactly one point. Okay? So I think we are going to take this into the next class, okay? Okay, I think we finished, and we are going to see each other on Thursday and Friday, okay? Okay, so good evening, everyone. Already almost evening. So okay, I think last time we talked about this after we discussed the parametric equations, which you can see from the characteristic that if we just taking the curve itself without the arrow and without giving any context about the t, the parameter t, we see that this one is not a function, right? But if we can make it like this and giving additional parameter t and we have the directions like that. Imagine like a motion for some particles, and then t like a time. Then we could make this as a parametric equation. Okay? And suppose that we can have each of the positions functions by the variable t. Okay? So it means that for the vertical position we can take the y, and for the horizontal position we can take the x. Okay? And after that we can also sketch that one, and then we can also taking the trigonometric variation that we could also include into our parametric equations. Okay, so now we are going to focus more on the calculus part, in which the first step is to get into the tangent. So the tangent, so suppose that we have the y equal f of x, okay? And usually when we are discuss about tangent, we are discuss about when we talk about the first derivative, right? If you remember, and we could take this and then equaling it into from x like that. So we are interested to get the dy dx. This is, we say, a slope of the tangent line. Okay, if you remember the calculus 1. So when we find the first derivative, it's actually the slope. Okay. Now in parametric, let me make it. In parametric, now we have x, let's say with a function of t, function f, right? And then we also have y, that is, let's say, g of t. Now from the definitions that the tangent line is dy over dx, it means that we are going to relate this y with this x to find what we need in finding the slope. Okay, now the best way to relate this equations to this one is to deconstruct or to separate dy dx into several parts. Okay, so what I mean is, if we could make, let's say we want dy dx. Okay, now remember in calculus 1 we have chain rule so that we can connect this dy with this t, and then we can also get the x at the end. So this is the product that we want. So we need to multiply. We need to multiply that this is dy dt, and this will be dt dx. So that we can get the final product, which is dy over dx. And then we can simplify this, and we can make it into dx over dt if we put down here. So we could take this. So this is from the chain rule from calculus 1. So we can write dy over dx as dy over dt divided dx over dt. Okay. Okay. So this is important. So let me put a sticker here. You got money here. Okay. But it's not the real money. Yeah.
Is that opposite? The dx over dt should be opposite.
Should be opposite.
And this is chain.
Oh, I'm putting down here.
No. Or am I wrong?
Hmm?
That dx over dt below.
Yes. dy over dt over dx over dt.
Isn't it dt over dx? Oh, sorry.
It's multiplied, but I'm taking down.
Okay.
You get it?
I thought.
Okay. Okay, there is some graph here, but I think the graph can be put down first. Let me put down there, and then we can have more space. And of course, I forgot to mention that the f and g are differentiable. Okay. So all the assumption for the derivative should be also included here. Okay, if you are maybe curious. So remember, in calculus 1, you need to have continuous function and differentiable so that you can have derivative. Okay? Because if it's not continuous, then you cannot have derivative. Okay, and then we take some notes here that the dx over dt, to make sure that this is defined on all real numbers, then this is not equal 0. Okay. Which means if it is equal 0, then we have some, perhaps if we have some graphs, then perhaps that will be the asymptote. Okay. Okay, let me give you some context and example on how we can apply this dy dx or the tangent in parametric. So let's say a curve C defined by, let me give you the expression, x equal t squared and then y equal t cubed minus 3t. Okay. The question is, show that C has two tangents at 3, 0 and find their equation. So what does it mean? Again, remember, when you are looking at the tangent, when the discussion is about tangent, it means that we need to find a line that perfectly touch one point at the curve. And we need to check whether this 3, 0 is that point. So first, since we already know that the tangent is actually the dy over dx, then this is the first thing we are going to make. So we are given this x and y. So we know the dx dt, dy dt, and then we can plug into our dy dx. We get the equation for dy dx, and we plug in 3, 0. Okay, that will be the dy dx, which means that this is the slope. Okay, and it says that it has two tangents, so we need to show whether it is two tangents or not. Okay, so let's just try to find the equation first. Okay? So let me write here. So dy dx. Let me just write the formula first. Dy over dt, dx over dt. Okay. Dy over dt, we can see that y is t cubed minus 3t, not really complicated. So we can just derive as usual with respect to t. This will be 3t squared minus 3. Okay, over, now the x equation we derive, this will be 2t. Now we have, this is xy. Then we need to check this into this equation first, and then finding which t that are applicable to our tangent equation. Okay. So first we need to check what will be the t when x is 3 and y is 0. So when x equals 3, y equals 0. So when x equals 3, that means that t squared will be 3. T is plus minus square root of 3. I think you can also check using the same conclusion here. So we can take t, I will factor out t, and then t squared minus 3 equals 0. So t can also be 0, or t can be plus minus square root of 3. But the one that is matched with the x is this one, right? So we are taking these 2 points. So you see that we have this plus minus, which means we have 2 slopes, at least, if we're taking it to this one, at least. But we need to check, we need to check. So we take, so when t equal plus minus, or maybe let me just write one by one. So when t equal positive square root of 3, then dy dx becomes 3 so 9 minus 3 is 6. 6 by 2 is 3. So 3 divided by square root of 3, this is just a square root of 3, right? Okay. And then when t is negative square root of 3, dy over dx, I will directly just adding negative to the bottom one because the above one is positive, so it will be negative square root of 3, right? Okay, I'm skipping some parts of it. Okay, so we have 2 slopes. The first slope will be the positive square root of 3, which is probably like this. This is positive slope, right? And the other one is the negative slope, which is probably like that. Okay, and at that point. Okay. So from this to slope, then we can make out the equations. How to write the equation? So add 3, 0, okay, or maybe if you want to make sure that this is correct, at x, y equal 3, 0, then we have the first one is y, it's coming from y equal mx plus c, right? or y minus y1 mx minus x1 like that. Okay. Since y is 0, then we can ignore that and we focus on this, the m, the gradient, and then x minus 3. And the other one will be negative square root of 3 x minus 3. Okay, so we have two equations now. This is the tangent line. We have two different tangent lines at this point. This is the picture of the parametric equations. Okay. So we have this one here and this one. But suppose that we don't know yet this graph. This is just to make sure. We have another question. However, we have at least 3 more questions, follow-up questions about this. Okay. I think I will copy this into next page so that it can be more spacious, so I can write more clearly. So let me cut first, okay, and I will let you write in the next page, okay? Okay, here. Okay, now the next follow-up question is find points on the curve C where tangent is horizontal or vertical. Suppose that we are not really know about the picture. Let me just make it smaller before we reveal the correct answer. Okay, now the key point on our tangent, aside from dy dx, is the slope or the tangent itself, the degree of the slope. We can also make the tangent horizontal or vertical. Because if you see the curve in parametric, this could happen, right? Before, perhaps in calculus 1, if we have the vertical tangent, it is usually nearby the asymptote, right? Nearby the asymptote. But now we have this kind of situation, and this is by the fact that it will appear on the curve, right? So what should we do for the horizontal and vertical? Let me draw a little bit on just a random curve like this. Okay. We see that the function, if this is a function, we get to know that this will be increasing, and we can see that we have a tangent. We have the tangent here. The tangent is still positive slope. But here, it starts to change, and at one point, at the exact point here, it will somehow reach 0 before it's going down, before it's going to negative, right? So we agree that the horizontal tangent is when the slope is 0. Okay, so horizontal tangent when dy dx is 0, and now we know that dy over dx is, in parametric, dy over dt divided by dx over dt. Okay, now if you want to make this equal to 0, which one needs to be 0? This one, right? Okay, so that's why horizontal tangent is when, so it's horizontal tangent is when dy dt equal to 0. Okay. And now imagine a curve that is like that. So the more you approach this curve here, it's increasing, right? But how much? And then if you make it like really straight, it's infinity, right? The slope will be infinity. That will be the vertical tangent. So, using the same logic, how to make this into infinity? Or how to make this becoming undefined? Before, we get to know that this should be 0, but now so vertical, right here, vertical need to be dy dx. Let me just write this is equal infinity first, okay? Although it's not really correct if we write like that. We need to use limit, but somehow this is to simplify our situation. So we need to make sure that we get this infinity. How we get infinity? Any idea? I think you know, but it seems shy to say. Any idea? Any idea? Any idea?
dx dt over dx over dt is
Should be,
near to 0.
yeah, it should be 0, right? You can say it should be 0. So to get this, then the dx dt is need to be 0. Okay, so vertical, let me write with the blue one. So vertical tangent is when dx dt equals 0. Of course, this I'm not writing completely. I will write here. I forgot to write that dx dt for horizontal is not supposed to be 0, and this one not supposed to be 0. Because if we have 0 over 0, that will be the indeterminate situation. Okay, if you remember, that is when we have the 0 over 0 situation, that's what we call indeterminate forms. Okay? That usually is solved with L'Hopital rule in calculus 1. Okay? So we need to make sure that this will be a number and this will be 0. Okay, so let's do that. So let's try to find out. So we check dy dt equals 0. So dy dt is 3t squared minus 3. We need to equaling this to 0, and we get that 3t squared minus 1, right? So t will be plus minus 1. So this will be horizontal tangent. I think this is supposed to be the correct one, should be just undefined. Okay, if I just write equal infinity, that will be a little bit wrong in definition. But if we use limit, we can use infinity. So we get the horizontal tangent. So the same way we can do that. So dx over dt equaling it to 0. And we get that this is going to be 2t equals 0. So t will be 0. Okay, now from all this t, we can make sure the positions. So let me write the equation. Y is t cubed minus 3t, and x is t squared, right? So check t equal 1. So when t equal 1, y is negative 2, x is 1, right? And when t is -1, y is 2, right? And x is 1. Okay. So we have 2 points, 1, -2, and 1, 2. That will be the point. So this is the horizontal tangent. And the vertical tangent is when t equals 0. So let me write here. Or maybe let me just erase this part. Yeah, it's kind of like cheating using digital. I can edit my file. Go here, let's go there, and this can go. Okay. So this is the vertical tangent. So we can take t equals 0, and then y will be 0, and x also 0. So we get that at 0, 0, we get the vertical tangent. Okay, I hope you get at least the steps from finding the just derivative or finding the slope. And then we can find which one is the horizontal, vertical, okay? Okay, we still need to have 2 more follow-up questions. This is the second question. So it's, I think, good for calculus 1 review. Okay. So I think this is not really complicated, right? Or it's complicated? No. It's quite not too complicated, right? Okay. Now let's continue to the next follow-up question, which is, let me take the new page. So the next follow-up questions is, what is the determine? Okay, determine where the curve is concave, upward, or downward. Okay, what is that? Okay, let me just show you a quick review. So okay, let's say we have this random curve. Okay, if we talk about the first derivative, the tangent, the slope, we are talking about when the function is increasing and decreasing, right? Like this and that, okay? We have a positive slope, negative slope, okay? But if you think carefully, okay, for example, in this case here, the slope, if you see, let me write, this is the slope, right? And then this is the slope, and then another slope here, and then another slope there, okay? If you compare one by one, okay, let's say you start from like 0 and then getting positive, like that, okay? But somehow, between these 2 sides here, we see that somehow the slope is not constant, increasing constantly, right? We call that point the inflection point, or in your calculus 1 review, that is when we are going to use the second derivative. Okay, so what is that about? So you can see that it's made like that, right? Like my hand, like the curvy, like that. And when it's changing here, it goes here, right? It goes different directions. The curve, okay? The sides is having different directions, and then somehow at some certain point, maybe it's going back to this way. When you have this, the left one, this is what we call concave upward. and this will be concave downward. Okay, I'm just making the important steps, maybe not really complete, but I hope you get the point. So you can also just using the capital, this is CU and this is CD. Okay. One way to memorize or one way to remember easily is, you see, it's U. So it's going up like this. And the other one will be that way. Okay, now, how to use this the second derivative? So the concave upwards is when the second derivative is positive, and concave downward when the second derivative is less than 0. It's negative, okay? Which means we are now going to check the second derivative, okay? Now how to check, now before we check our questions, now how to check the second derivative of the parametric equations. Now let me write here. So previously, let me write again. Previously we have dy over dx is dy over dt and then dx over dt, right? Now if we take the second derivative, let me write first. This means this is the derivative from dy dx. Okay? Now the interesting part is through this part here. Okay? What we need to write. This sometimes because we get the first derivative like this one, sometimes we think that, let me write first. Sometimes we think that the second derivative is this way. Okay, sometimes we think it seems this way. And I will mark some remarks here that this is wrong. Okay. Okay. Now, why is that? Now we need to remember that all the dy and dx here, this is getting from that we force that the y is function of x, but each y and x, they are function of t. If we make this is not based on any relation. So if we are going to make sure that we are stay on the same definition, that is y, let me write the definition first, that we need to have the definition consistently. So y is f of x, and x is, let's say, f of t, y is g of t, okay? Or maybe let me use different f to make sure it's that means different. So what we need to do is we are going to take this derivative the same way we did with this, okay? So we have now so d dt, this is dy over dx, and this is dx over dt. Now this is the second derivative. So based on the results we get from the previous calculations, which results in dy dx equal 3t squared minus 3 over 2t, right? Then we need to input inside the second derivative, and I forgot the x dt is 2. 2t, right? 2t. Okay, so the second derivative, so d dt 3t squared minus 3 divided by 2t. Oh, wrong. Should be having the other here. Should be fractions 2t like that. Okay, now we are going to have a differentiation using calculus 1 techniques. So we have a fraction like this. Okay. Let me write some review here. What to do if you have that kind of situations. So if you have y equal f over g, okay. So if you want to find the first derivative, this will be f prime g minus g prime f divided by g squared. Okay. So do the same thing with this equation. Okay. Now we take f on top, g on the bottom. So we could make this and let's say this is 2t and this is another one, 4t squared, and f prime g we are going to have 6t, and then g is 2t, so 12t squared minus 2, and then multiply with 3t squared minus 3. Okay. Okay, and then calculate. We have 12t squared minus 6t squared becomes 6t squared plus 6, right? So 6t squared plus 6, and then the 4t squared going down, it will be 8t cubed. Okay, we can cancel some part of it, then we can simplify. Our second derivative, 3t squared plus 3 divided by 4t cubed. Now, how to check the concavity now? Remember, we need to check concavity, whether it's concave upwards or concave downwards. Concave upwards is when this positive, or concave downwards where the second derivative is negative. Now, how to check that this is concave upwards or downwards? We may check some numbers, but what kind of numbers we would like to check? So I think this is, especially in mathematics, this kind of intuition you should have. Okay? So if you see any rational functions like this, one step to think is to think the denominator. Okay? What's happened if the denominator may be 0? Okay? Or we could think also what's happened if all this equal to 0. Okay? We could also think that way. So I think we don't want the t to be exactly 0, right? Because if t is equal 0, then it would be undefined, right? So let's say we are going to set that t equals 0 as our concern in line numbers. So we draw the line numbers. And then take the t equals 0 there. And then check whether when it's positive, what will happen, and when it's negative, what will happen. So let's check t equals 1. I think that will be positive. And when it is negative, since it's having a cube here, it will be negative, right? Because it will be multiplied by the negative numbers. So check, and then we get that this will take negative and positive, which is this is concave upwards and this is concave downwards. So t greater 0 will be upward, t less than 0 will be downward. Okay? Now based on what we have from the beginning, from the finding the slope, the horizontal tangent, vertical tangent, and then the concavity, the next follow-up question is to sketch the graph. So sketching the graph, I think I will just erase this part. Okay? This is just a calculus 1 review. So let me graph this parametric curve. So the first question, we have the 3 and 0 point, right? So 1, 2, 3. So this is 3, 0. That there. And then we have 2 points, 1, 2, and 1, negative 2. So perhaps this is 2. This is negative 2. So we have here and here. So we can draw the horizontal tangent here. So the tangent will be our guides now. So the curve should be touching that line. And also at 0, 0, we have the vertical tangent. So here is that. Okay. And then remember that at this point here, when we have the 1, 2, this is when t is equal negative 1, right? And when we have this is when t equal 1, which means that somehow we are going to move from this point to this point. And we need to also include the 0, so the probability will be is going here, right? And then we also know that we have this concavity. And then we know that at the 3, 0 here, this is t equal positive square root of 3 and also negative. So it must be crossing this point twice. Okay? So if this is going to be from here to here, then it should be going here, going there, and then going back. Okay? Now you can imagine when t, let me write t greater 0, t less 0. Remember, this is t and our graph is in xy. So we focus on this t. So t0, t negative 1, t0 is here, right? Let me just grab my t equals 0. So this is t equals 0 at 0, 0. So when t is greater 0, which means, which one is t greater 0? It's positive, right? This one, right? Okay? Which one is t negative? Going up there, right? T equals negative 1. So that one, downward, upward, downward. We match all the calculation, right? So we can draw that, and then we could make our curve. So let's say we are going to take that, going there, and take that, going there,
and then we go up, going there, okay, and then we go that way, and then we have this is another tangent line and another tangent line that we previously confirmed, right? This is the y equal square root of 3 x minus 3, and this one is y equal negative square root of 3 x minus 3. Okay. Oh, let me copy the one that is in the correct. So let me copy here to show you. Okay, I think not bad, right? Oh, I forgot the arrow. So arrow should be from this part, that part. Okay, any questions? No? Okay. So if I'm giving you like a similar step-by-step questions, should be familiar, okay? Okay, since we have only around 3 minutes left, I think this will be the end of our lecture. Okay. So do you have any questions? We still have tomorrow, right? Okay. Yeah, it's weird schedule, like 1 hour, 1 hour, and then 2 hours. So I will upload the videos today and the previous one, and then combine one and try to upload it hopefully tonight or tomorrow. Also tomorrow I will upload after class. Okay? And because I'm using some AI tools to give the subtitle, sometimes it's not really accurate and sometimes it's ridiculous. So I hope you don't mind. Okay? But I think 70-80% is correct. So there will be some missing or typo in the subtitle. Okay, I think that's it. But before we end, I would like you to, which one is this? Oh, this one. Please scan this one. And you'll be in the Google form that is supposed to be your self-evaluations, which includes attendance and about your learning. You can write anything, like if you feel the class may be boring, you can just tell me which part, maybe specific again, which part, maybe some parts are okay, maybe some parts are not so good. And if you have done it, then we finish the class, okay?